All right, but here's where we got. Here I am, and then maybe we'll show the board, and I kind of like that sometimes, but I'm already in the way of the notes. Move myself up here. Now I have to move around. Okay, we're gonna graph this input output. So I plug in 0, I do get 0. So yeah. And then when I plug in 1 squared is 1, but then half of that is a half. So if I go here and here, 1 comma half, -1 comma half. And then -2 squared is 4, but then half of that is 2. All right, and then 2 squared is 4, but half of that is 2. All right, so it's a compressed or shrunk vertically compared to the parent, and we're going to keep hammering on those ideas as we move forward. But then when I look at this interval, I'm actually going to have to plug in -4. That's what this means. Over the interval from -4 to -2, what is the average rate of change? So I'm going to skip to -4 and plug that in. -4 squared is a large 16. Thankfully, half of that is 8. All right, where would 8 be? Let's just put that as a coordinate up here, and I think it'd be 2, 4, 6. Who do we appreciate? All right, so -4, somewhere around up there. Then this is the picture. Now I want to climb into your head. I want to talk about a calculus word. It'll probably be more like flipping up that way, but at least a good sketch. Calculus word, I'm going to do this with my hand and show the picture here if you cared, is a tangent line. And here's what a tangent line is. And I'll draw one at our first coordinate or second coordinate that I have right here. A tangent line is very special. I meant to hit green. Very special at particular points. There is one and only one tangent line for each point on the curve. All right? A tangent line is a line that crosses that curve once and only once, but stays on the same side of that point. So it skips off, like a rock on water. It skips off and stays above the water. So it never crosses through to the other side. That could be the only tangent line at that point. I change its direction. Now it's hitting that parabola twice, not once. Everyone understand what a tangent line is at this point? Hey, what slope is that? Is that positive or negative? What kind of slope does that line have? Positive or negative? Negative. That's what this is part of what a derivative is. Like you're finding derivatives in calculus. You don't have to know what that means, but derivatives help in finding slopes of tangent lines on curves. And really what it is the instantaneous slope at that point. What do I have? Now let's flip over to the other side. What kind of slope is this for this tangent line? Positive or negative? Positive. Now we have changes there. I got a real big concept. What's the slope of the tangent line at the vertex? What is that slope right there? Ooh, we got to remember from last year. I heard someone say it. What's that slope? 0. All right. At the vertex, the slope turns 0. All right. And then when I go here, this is going to be hard to see, but I think you get it. I'm trying. This line and this line. Let's call this 1 and call this 2 for those two. Who has a steeper slope? 1 or 2? 1. So as you keep going, and that's the point of, what's happening by the vertex. The slopes of the tangent lines are kind of small. But as you keep moving up here, the slopes of the tangent lines get steeper and steeper and steeper as you move away from the vertex. Does everyone understand what I'm talking about here? All right? Very simple. So I like this question because it kind of is intimating, like talking about rate of change, but they're talking about rate of change between two coordinates, not one. So actually what they're looking at is, what is the slope of this actual line? This line that crosses this parabola like that. So really all I need is these two coordinates. This coordinate right here is -4, comma, I think it was 8, right? I plugged in -4 and I got 8. This line right here is, or this point is -2, comma 2. Okay, by the way, before I continue, This is not a tangent line, all right, because it crosses twice. It's called a secant line, all right, and that's a calculus concept. I have a secant line. As this point gets closer and closer to this one, you're getting closer to a tangent line, and that's the whole backbone of what a derivative is. All right, really kind of cool stuff. So anyway, what's the kid's error then? Look at that. What is the kid's error? Error analysis. They have the wrong what? Starts with a C, CO, COO, coordinates. The y coordinate's wrong. Their slope formula is right, but they have the wrong coordinates for the y's. All right, so that's what you would write after all of that. So they wanted to know the slope of the secant line is what that actually is. Or the rate of change from -4, the average rate of change is actually the slope of that line that connects those 2 points. Rate of change, slope. Okay, that's really a similar thing. All right, go ahead and turn in your homework now. If you look at my calendar, I'm going to try to do this for you. This is going to be a long, long video for those that are at home. Hopefully, you guys all scanned in. I don't have time to go check the attendance. So hopefully, y'all scanned in correctly. Notice I'm going to try to color code to help you guys out. And I think we did all right, although I'm not sure everybody put their homework in order chronologically, which I did ask. I didn't really check for that, I guess, this time. But I tried to make it a brownish color. The next stamp is going to be chocolate. You smell it, and it smells like cocoa chocolate. A lot of fun. But it'll be brown in color. All right? And then that's how your homework's going to be color-coded each section at a time. I don't know. I forget if we have a quiz or we just have a test at the end of this chapter. I think it's just a test, no quiz. Sometimes we break chapters in half and throw a quiz in the middle. Thinking about doing more homework quizzes, it's like a pop quiz. You come in and check if you're following along daily. Like I said, it doesn't work when we take 2-3 days off and think we can turn in the homework whenever we want. It doesn't work in math. I don't know how it works in any other class, to be honest. I don't know how this is even a philosophy, at all. I do understand if you miss, you need a couple days to get back, but the more time you take, the more behind you get. In math, it is catastrophic. Okay, so today we're going to break down. You may already know this, and I don't care. There's some in the seats that need to see this, all right? And maybe many of you do. I don't know where you're at. I don't know where you're at with changes to a function and how it affects the picture. That's what today is. Well, today you can already see, too, it's section 3.2. We will call this chapter 3. And it's vertex form. So you can see that up in the upper left corner if you want to head it. Don't put this exactly as it is. Example 1, and try to draw this hand with the finger up there, whatever. You know what I'm talking about. Shorten your notes. Be a good note taker. First thing you should write is the parent function. And then everything that we talk about after this is based off of the parent function. Input, say it. So 0 squared is 0, 1 squared is 1, -1 squared is 1. 2 squared is 4, -2 squared is 4. That's why this is the graph. This is what graphing is. It's input, output, then collect those coordinates and graph them. Everything we're going to graph this year, we're going to start by input, output. We're going to see the parent by doing that. And then even when I do other functions that are not the parent function, we're going to think about input, output to make sure we have the right picture. Drives me nuts, my CAT students, they don't have that basic idea of what a graph even is. And the ability to evaluate in order to get that picture. Okay, so right off the bat, I'm going to go to input output. Because I know what's going on, I know the first coordinate I'm going to plug in is still going to be 0. And I put it in the middle because I know 0, comma is going to be my vertex. The reason is I know what the +3 does. And that's what we're going to get to and try to get to for everyone in here. What does the +3 do? Don't answer that yet if you already know. By the way, 0 squared is 0, but +3 is 3. So 0, comma 3, input, output, put the coordinate where it belongs. Now, how do you find the next coordinates? Each coordinate 1 away from 0. And then I'll prove that this is the vertex. what you'll start seeing right away is the symmetry aspect. Exact same y values. 1 squared is 1. 1 plus 3 is 4. I should get the same thing with negative 1 if 0, 3 is actually the vertex. Negative 1 squared is 1. 1 plus 3 is also 4. 1 comma 4. Negative 1 comma 4. I'm going to stop right here and tell you something that we should know in the future. Not when I say should, it's not that you should know it now, but just to make this connection. Look at from the vertex to these next set of points. Look at the first order difference is what I'm going to call this, or at least look at the slope from this point to this point. Rise 1, run 1, right? Then rise 1, run 1 left. So from the vertex to the next integral points right there, the A value is given by how far that is rise over run. Just the first set of points, because watch the next set of points. 2 and negative 2. 2 squared is 4. 4 plus 3 is 7. So 2 comma, now it's starting to take off. The next set of differences is 3 away. Okay, so now this is messing. So I go back to the vertex, next set of coordinates, whatever the slope is to get to those, that is what the A value actually is. And then listen to this. That's my symmetry. I know I'm going to get 7. Negative 2 squared is also 4. 4 plus 3 is 7. So it's proof that this is the vertex. The symmetry in the next set of coordinates, moving from there to there. Okay, now, I don't want to say slope when we're dealing with a parabola. Parabolas are curved. There is nothing linear about a parabola. It is curved. The next set of points starts taking off, all right? And this gets steeper and steeper, like I showed you in the bell work, or showed you in that, how do I do that number 11, you know, the idea of tangent lines and how they get steeper as you move farther away from the vertex, right? So do understand that. You can't convolute the things that I'm saying. By the way, there's still an axis of symmetry here of 0. Oh, what is this compared to the parent? This got moved up 3. So when we use that terminology, what happened and what's the change? It's compared to the parent function. How is this new one different? And I think many of you would have known that beforehand. And then when we get to the final, like what's the formula for what we're dealing with here in vertex form? I'm going to say something about all functions. Still 0, but in this case, when I plug in 0, I get negative 2. So I bet you we'll have a down 2 situation. But let's prove it with some other coordinates and go faster. 1, 2, negative 1, negative 2. I love this program. It had such a better note format back in the day called Windows Journal. Anyway, nobody cares. OneNote. Help me, Microsoft, make a better product. 1 squared is 1. 1 minus 2 is negative 1. 2 squared is 4. 4 minus 2 is 2. Negative 1 squared is 1. 1 minus 2 is negative 1. There's the symmetry. Negative 2 squared is 4. 4 minus 2 is 2. I can't help you with evaluating. If you cannot square a negative and get a positive, that's all I got to say about that. All right? Was that even words? 1 comma negative 1. And then 2 comma. Now it starts taking off a little bit. 2. Negative 2 comma 2. Same shape. Axis of symmetry. Still x equals 0. But it is moved down 2 compared to the parent. And I'll draw that line. Comparative to the parent, we would say this moved down 2. And that's actually what's happening in this special case, or these cases. Let's say special, but may I move on? All right. Now it's these two. And actually what I have for this blank again, don't draw it again. Just arrow to the parent again. But I will sketch it real quick. 2 squared is 4. 1, 2, 3, 4. Negative 2 squared is 4 again. Don't draw this again. You already have it drawn in your notes. The next 2 examples are going to be compared to this yet again. I just want to see it one more time. Y equals x squared again. Okay, and then the two things, x plus 1 squared. Oh, that's different. I call this inside the function. It's part of the squaring. X minus 5 squared inside the function. And I'll tell you where we're going to start on this. I'll zoom in if those are too small to look at. I'm going to zoom in here, and I'll tell you exactly what I'm going to plug in on the chart here because I know what I'm doing. Of course, I've done this for years, so I should know what I'm doing. Not going to plug in 0. I'm going to plug in -1. You know why? -1 makes this inside 0, right? What's -1 plus 1, everybody? 3, 2, 1. What's 0 squared? 0. And I'm going to prove that this is the vertex. -1 comma 0. The proof of it is to go 1 away, up and down. Yes, -2 is lower than -1. So they're both 1 away. I should get the same y coordinate. And I will. 0 plus 1 is 1. 1 squared is 1. -2 plus 1 is -1. -1 squared is 1. Boom, shaka. Anyone? Laka. Thank you, whoever said that. Yet again, look at the a value. The a value is 1. Look at from the vertex to these next set of points. 1 over 1, 1 over -1. 1 is a slope, rise over run to get to the next 2 points in the symmetry format here. All right, and then going up again, going up 1 and down 1, these should have the same. 1 plus 1 is 2. 2 squared is 4. I better get 4 for -3. I do. -3 plus 1 is -2, but square it and you get 4. All right, so 1 comma 4, 1, 2, 3, 4, and then -2 comma 1, 2, 3, 4. Even if you knew this, it's still good to discover. By the way, that axis of symmetry is x equals, -1. It got moved by symmetry line. So therefore, and also you see with the vertex, you would say this is left 1. Compared to who? Compared to you. All right? Now I should call on you. I'll wait till tomorrow. I'll call on. So I'll get the calculator. I'll give you a day off from the calculator stuff. I really do that to make sure you are focused on what's going on. Sometimes I do have bums that fall asleep during the notes or just like decide that they're not going to take notes and whatever. So just keep you on task. But what am I going to plug in for x now? I'm going to ask this in 3 seconds. What am I going to plug in for x for the vertex? 3, 2, 1, go. 5. Did you hear all your friends? Nice. And I didn't tell you, I also tutor in 3B, and I'm getting Math 3 students regular. And actually, Math 3 honors are doing something similar too. But Math 3 regular, they're doing all this, like not with just parabolas, but they're just analyzing pictures and knowing where the vertex is, if it's a parabola. Or you guys did absolute values, right? That are V's. Anyone do absolute values last year? I think we'll see those again. Very similar to a parabola, but the V's are linear as you go like this. Parabolas are curved. There's a big difference, and you better show those curves. But anyway, very similar. A year from now, you'll have similar terminology, but then take it a step further, like domain, range, increasing, decreasing intervals. Where's the function positive? Where is it negative? I may hit that tomorrow because those are really good questions for tomorrow's form. 1, 2, 3, 4, 5. Just wanted to make sure I counted. And then I'm going to go 1 away. Go up 1, down 1. 6 minus 5 is 1. 1 squared is 1. 4 minus 5 is -1. But -1 squared is also 1. And there's the proof of that symmetry. And then 7 and 3. 7 minus 5 is 2. 2 squared is 4. 3 minus 5 is -2. Square it and you also get 4. 1, 2, 1, 2. Okay, I just used symmetry there. Okay, good. And then this one is at x equals 5. The line of symmetry. Vertical lines, x equals a constant. Lock it in. All right, this is right 5 compared to the parent. You just draw your line to the one that you had up there for the other examples. Okay? Now, putting it all together. Go ahead and take this down. I'm going to blabber about this form. This is what we just discovered. I'm going to blabber about how this affects all functions the same way, not just squared or quadratics are what these are called. First of all, from yesterday, we started with that. Vertical stretch. If A is bigger than 1, then it's stretched vertically. Does make a parabola look skinnier. Never say that, though. And then vertex is between 0 and 1. That means a fraction that is less than 1. Then it shrinks or compresses is sometimes the word vertically. Then notice I put in blue. Separate from stretching and shrinking is the idea of A is negative. That's just a flip. And I'll take the word flip. That's fine. Flip over the x-axis. I'll probably say that more than I say reflect. Okay, so flipped over the x-axis if it's negative, and then you have to analyze if it's, after that, is it a stretch or a shrink? Negative has nothing to do with stretch or shrink. Nothing. And then this is what we just did. Okay, we just overanalyzed what happens when you insert a number inside the function. What does it do? And I want you to understand this. This is what I had to tell a Math 3 regular student yesterday, just yesterday. You got to get this down. When you see a number on the inside, it is a right-left shift. You want to think opposites of what you're seeing. Let's take a for instance. What is minus 5? What's a negative 5? Which way is that on the x-axis, right or left? Which way is a negative 5? Left. But what did it actually do? It actually went, sorry, it's over here. What did it actually do? It went right. And really it's because what do you plug in for x to make the 0? 5. So it's actually positive 5. It's 5 right. So I told that student, whenever you see a function like this, you got to think opposite on the inside, and then look at your beginning examples. Same on the outside. I think we had x squared plus 3, right? Wasn't that one of our examples? What did the plus 3 do on the outside? Did it move it up or down? Up. Look at your example if you take notes. So plus 3, that did move it up. So I think the same. Positive 3 is up. Negative 5 is right. Ooh. Right? When it says x minus 5. Opposite, same. And then as you're finishing writing this down, sorry if I cut off those words if you're really, really, really a note taker. This is the same if this was, and don't write this down, just watch. If that was a cubic, we're going to do that this year. I believe we're going to graph square roots. Sometimes I get cat and you guys mixed up. If it was a square root function, these are all the same, these changes in the function. Hey, you said you did this last year? Then you should have had this concept last year with absolute values. So if I get rid of this and it's an absolute value function, you have a v that's affected the same way. Stretch, shrink, move right, left, up, down, all right? So we should have seen this before. Every single function affected the same way by this format. For a quadratic, this is called vertex form because the vertex is the main point that is the starting point of the graph. And h comma k represents the vertex. Okay? All right. Popular questions here. And then I'll prove this when we get our last big example that I'm really going to hack apart. Well, it's not our last example, but the most important one where we put it all together. Okay, yep, so I thought 9:30. So taking this picture here, this is all we're doing if you want to shorten your notes. What's the equation? That's it. That's all I'm asking. From this picture, what's the equation? That's what we're doing. All that stuff up there. What information do the values of h and k provide about the graph? Well, I think we understand that that's the vertex. It's not only the right, left, up, down shift. It's actually what the vertex is. We can prove this by input. Say it. Output. And I can prove that the a value, again, is 1. Okay? First of all, why is it 1? Look at this point, and then look at this point. And I did this last hour too. Rise one, run one. Rise one, run one. Stop there. There is no more slopes like that. The next critical point is 3 over 1 away. I think the next one's 5 and 1 over, but you don't have to know that. All right, that's actually true how these work as we move through the chart of values. So we know the vertex is 1 comma negative 3. So what is the equation? Is it x plus or x minus 1? Which one is it in 3, 2, 1, go? Oh, here the plus and here the minus. All right, you know why it's minus 1? Another way of looking at it is how we did the chart of values. When I plug in 1 here, what's 1 minus 1? What does it end up becoming? Well, 0. All right, that's what you really want to focus on. All right, and then what's on the outside? Plus or minus 3? Which one is it? Plus or minus? 3, 2, 1, go. Minus, because we went down 3. Input, say it. Check, am I right? If I plug in 1, do I get negative 3? That's what a coordinate is for a graph. It's actually the point that exists on the graph. 1 minus 1, 0. 0 squared is 0. Minus 3 is negative 3. Boom shakalaka. All right, so this is what the case is. This is how we find an equation like this. How do I know it's 1 in front? Rise over run for the first next set of points, and only those set of points. Same thing here. Rise 1, run 1. Rise 1, run 1. We're going to have 1 as a value out in front. I already do. Vertex, to not over-explain this, is negative 2 comma, and it's negative 1. So what do we have on the inside of the parentheses? Is it plus 2 or minus 2? So just say plus or minus. 3, 2, 1, go. Oh, did you hear some people say minus and some say plus? That means we're not there. What's the actual answer? It's plus 2. Why? What's negative 2 plus 2 when I plug in negative 2 for x? What do I get? 0. It's whatever makes that inside of the parentheses 0, that is the right-left shift. So it's 2 left because it's negative 2 there. But it's plus 2 in the equation. Opposites. That's what we got to get down. And then for the minus 1, or negative 1 here, is it minus or plus? 3, 2, 1, go. Minus. For outside, it's same. Input, say it. I'm not sure of this yet. Am I right? Negative 2 plus 2 is 0. 0 squared is 0. 0 minus 1 is negative 1. I inputted negative 2. I got an output of negative 1. This is a coordinate. So I know I am right. Quick question? That'd be fine. The question was f of x, can I write y here equals? And I wouldn't be mad about that. That's just function notation. And then that's just hammering the point. F of x is the same as y. F of x is the output variable. So, but we better get used to that though, right? And then just checking real quick. Hey, I should get negative 1 comma 0. And then that proves that this is 1 out in front. Negative 1 plus 2 is 1. 1 squared is 1. 1 minus 1 is 0. So that I just checked that this point does actually happen. So I should be good. Okay? So these are checking points to make sure that your equation that you wrote is actually the equation that matches this. Okay, so you don't have to write this down, but I'll read it, being a nice little story from Mr. Samuels to the kids. The values of h and k determine the location of the vertex if we haven't figured it out right now. So we were talking about right, left, up, down shifts, but for a parabola, it's actually the vertex sitting inside this equation here. That's why this is called vertex form. The vertex is staring you in the face, right? And you know what it is. And the axis of symmetry. So look at what the axis of symmetry is. Whatever the vertex's x value is, that's what the axis of symmetry ends up being, which I wrote in every single question. Actually, I did not. What a bum. Look at this. Axis of symmetry. I like doing them as a dotted line. That's at x equals 1, which is actually the x coordinate of the vertex. This one is at x equals negative 2, the line of symmetry that cuts this graph in symmetrical half. the x-coordinate of the vertex. So that was a good thing I read that to you. All right, now we're going to put it all together and then answer these Math 3 questions that I was helping a girl out yesterday with from Math 3 regular. And then Math 3 honors, oh, they were taking it even a step further, but not just with parabolas and V's. They were really just a bunch of different pictures, let's just say. And a lot more complicated questions that we'll go through this year. All right, you know what I'm going to still do? I'm going to do a chart of values because we're at the beginning stages of this. What am I going to put right here? What am I going to put in for x? What number demonstrates the vertex? Go ahead. And then we're just double checking that I know what that vertex is. And the reason I'm also going to do this is because I'll show you the idea of what -2 does for the graph as far as the stretching is concerned. So that when you look at a picture, you could probably find the a value right away in your head. All right? But -1, watch what happens. -1 plus 1, 0, the 0 of the parentheses. Square root of 0. PEMDAS, by the way, I just did exponents. Actually, I'm wrong. I did parentheses first. -1 plus 1, 0. Then I did exponents. Squared is 0. Then I did multiply. I see a lot of students in every class don't know PEMDAS and don't do it right. That's still 0. 0 plus 5 is 5. So darn tootin', the vertex is staring me in the face. Vertex is -1, 5. Proving and hammering down the main idea of the notes here today. Okay? Axis of symmetry, we're going to call it AOS. And I guess I'll put sim. Should be x equals -1. So if I access the vertex correctly, this is where the graph should take its turn, you know. By the way, which way should this parabola be going? Up or down? 3, 2, 1, go. I only had one person. Let's do it again. 3, 2, 1. If there's the parabola going up or down, 3, 2, 1, down. Okay, at least copy that one person that actually said it. Yesterday's notes, when there's a negative on the outside, this goes down. We're going to prove it just with one set of coordinates, 0 and -2. I would have called on someone for this. Evaluate. 0 plus 1 is 1. 1 squared is 1. 1 times -2 is -2. -2 plus 5 is 3. And -2 plus 1 is -1. But -1 squared is 1. 1 times -2 plus 5 is also 3. There is your proof. I have a vertex. Notice from the vertex to the next set of like integer coordinates that I go down 2 and over 1 and down 2 and over 1. There's the 2 in front, the a value. There's the stretch vertically. You don't need to keep plugging in points for this. All right, I could probably use 2 more, and I probably should have. Fine, I will. 1 and -3. 1 plus 1 is 2. 2 squared is 4. 4 times -2 is -8. -8 plus 5 is -3. Hopefully I didn't do that too fast. Let me check -3. -3 plus 1 is -2, but -2 squared is 4. 4 times -2 is -8. -8 plus 5 is -3. So I should have done that. 1, comma. Well, I should have got a lot steeper, right? There's that stupid program. Sorry, I get very upset with this stupid OneNote. It constantly toggles stuff and changes and ruins my pen, and it makes me say nonsensical words. Growl. Annoying that 8 years after Windows Journal, I have a program that doesn't function near as well as one 10 years ago or 8 years ago. Anyway, I'm done complaining. Okay, so there you go. It's going down. All right. What did I say about x squareds? What can I plug in for x? That's what domain is. And the answer is anything. So this is the same thing. I said this yesterday. There is no restriction on what I can plug in for x. I can square any number, positive, negative. You'll see later when we get different functions, there are going to be restrictions for the domain. Hold off on that. The range is what is y. Wish I could call on someone. We're going to ask these questions tomorrow, so you better be ready for it. But here's the range, or at least here's where it's not. None of these y coordinates exist for this. Right? So there's a limit on the range what y values are covered. It's all of these are covered. Twice these y values are covered. I never understood why students have a problem with range. If range means y, it's just asking what y values are covered. But here's how you got to write it. I know the top y value is 5, but you don't start with 5. You go in number line order. Then I'll talk about that Math 3 regular student. She had a hard time with brackets and parentheses. It's a bracket because 5 is a range value. 5 exists as a y coordinate. It's the highest y coordinate that exists. Oh, I forgot to talk about extrema. We'll talk about that later. The fact that this has a maximum, actually. This is the maximum y value. But we'll talk about that tomorrow, and I'll make sure I'll insert that in the notes. So it's a bracket on 5 because 5 exists. Now, intervals of increase, we did this yesterday. When I read left to right, this graph is going up. Remember, that's describing the y's. You need to tell me what x's I plug in to make those y's increase. So I plug in these x's. Here's my y finger increasing as these meet, boom. And then at this point, then it starts decreasing. So it's these x's I plug in. But again, it must be in order. From negative infinity to negative 1, when I plug in these x's, I get the increasing behavior for the y. And that's how you better start getting this figured out. Biggest error that people put here is negative infinity to 5, because they're naming the y coordinate. And that's not what happens. That's all I can tell you. And then y, a parenthesis, it kind of can go back to what I told you the slope of the tangent line is at negative 1. What's the slope of that tangent line right there? What is it actually? 0. What's the slope of these tangent lines? They're all what kind of slope? Positive or negative? Positive. This is all intertwined together, right? These things. That's why we care about this stuff. So at negative 1, is it increasing or decreasing? No. That's why we use a parenthesis there, not including. Right? And then really getting the idea of what including and not including means. I'll erase that tangent line, getting all specific with that. And hopefully you know that this is from negative 1 to infinity. Okay, I see some people tuning out. I could see that it's hard to keep taking. That's why I call on you, because then you get fired up your brain in that calculator. So we're going to hit that tomorrow and make sure, hopefully get every single person to answer a question. Sometimes I do that. I just say, forget the calculator. We're just going. Student 1, you're 2, 3, 4, 5. Yep. All right. And then sketch the graph. We ain't going to do a chart of values. And I'll show you how quick you can do this one. This is when I should be able to call on someone to see if you're paying attention. We'll hit you tomorrow. Not hit you. All right. Vertex. Everyone, is it 2 or negative 2, comma? 3, 2, 1, go. 2. Opposite. Everyone, is it 1 or negative 1? 3, 2, 1, go. 1. You could do a quick input-output to prove that. I think we've hammered that point down too much. The axis of symmetry is not 2. It's x equals 2. You write 2, I'm marking you wrong, because that's not an equation of a line. You just threw a number on the paper. So axis of symmetry is x equals, because that's the equation of a vertical line. Get that locked in. Then it does say a quick sketch. So, I'm going to run into the next one. So we'll kind of do this. I'll put this graph right here. 2, 1. Watch what I do. First of all, which way does this go? Up or down? Down. You're waiting for the 3, 2, 1. Sorry. And then watch what I do. Since it's negative 3, I'm going to go down 1, 2, 3 for the next set of important coordinates, and then 1 left and 1 right. That's really what the A value means for the next important coordinates after the vertex. and there is the stretch. Okay? All right, next one. I think you got it. Vertex. I don't think we need multiple examples of this. It's opposite, same. You can prove this by input output real quick if you're still cloudy on the idea. Plug in -1, I get -4. So yes, -1, -4 is the vertex. And then the axis of symmetry. In this case, I'm just going to do AOS. Yep, seeing our time. X equals -1. Then a quick sketch. I guess I'll go over here. So -1, -4. Sorry, got to focus. 1, 2, 3, 4. And sometimes these notes do take a long time, and you've got to deal with it. All right, high level math class. Rise 1 and run 1. Rise 1 and run 1. Look at the A value is 1. You probably could input some more coordinates, but I'm not just because of time. I want to get to our next and what could be considered my last example, but I do have to do something. Okay, and that's what they asked. Vertex axis symmetry sketch. It does go up, and that's good enough for me. Okay, now, this is a very popular, we do this in CAT. Actually, this is coming up in CAT as well. A lot of redundancies in math. We want to make sure you know your basic skills. But with CAT, they have all of the functions in their mind, and then they have to access the right equation in order to answer this. But just to make you understand, tomorrow is a different form. Monday's another third form. And then Tuesday, we're going to jumble all the forms. You got to know what to access. Which one am I dealing with? Which form should I use? Well, what is this obviously? What is that for the parabola? What is it? It's the vertex. So guess what? On Tuesday, when you see this picture, you're going to say, that's the vertex. So I'm dealing with vertex form. You don't know of any others right now, but I'm just trying to get your head like in the future a little bit. So that's the one that I'm going to access. This is vertex, so I'm going to use vertex form. You probably could come up with the A right away, but don't do that right now. By the way, what do you think A is going to be? 2, because it goes up, but we'll prove it. By the way, what do you think I should plug in for -1? Or -1, I should replace that with which variable? Y, A, X, H, or K? 3, 2, 1, go. Ooh, I heard an X, and I didn't hear anything else. Not X. Let's go over again. 3, 2, 1, go. H. It is very specifically, yes, it's an X coordinate, but you're going to plug that in for H because it is the vertex. And that's what we're understanding about this vertex form now. Okay, 3, 2, 1. What am I going to plug that in for? K. It is a Y value, but it's actually the K that never changes for this one picture, for the specific picture. Now, there's an infinite amount of X comma Y's all over the place, but they happen to give me this one. So what am I going to plug this in for? 3, 2, 1, go. That's an arbitrary X, and that will go in this position. And then this is a bad color. What's that going to go in? 3, 2, 1. Oh, 3, 2, 1. Y. And then what is this going to lead me to find? A. Okay, and then I'm going to hurry up and finish this off. -1 equals A. This always makes me sad. PEMDAS. Students that get this far and then can't evaluate this. That's grade school, and I should be able to say that. PEMDAS means parentheses. 1. PEMDAS means exponents. 1 squared. Now, it really isn't PEMDAS. At this point, it's how do I solve an equation? If this wasn't 1, let's say this was 2, what would I do first? Get rid of the -3 or get rid of that number in front of A? Which one would I get rid of first? It's the -3. Sometimes people add these together and make this like -2A. Now our simple equation solving goes out the door, right? And that kind of drives me nuts too. So it's not really PEMDAS. It's you get rid of minus first, and then A does equal 2 because 1A is A. So we should be able to figure that out. All right, and this is where I ran out of time with the other class. And you can go and pack up your stuff, but the final answer needs to be written. You bring Y back because there's an infinite amount of X comma Y's, but then you insert the vertex in then, and the a value, and that is the equation of this parabola. Now, you guys go ahead and leave. Maybe watch the last 1 minute of the notes to see what I do with this last question. Let me finish. See, what do you got real quick? Because I got to finish this note. You go to the room you're assigned. You don't go to your compass room. Okay, height of a ball thrown into air is a quadratic function of time. The ball is thrown at a height of 6 feet above the ground. Okay, so that you have to understand is at 0 seconds. So at 0 seconds, we are 6 feet above the ground. Hey, that could be me. I'm a little taller than 6 feet. I'm 6'3". But as I'm throwing the ball, I might release it right here, which might be right at about 6 feet. So it's implied that this is at 0 seconds, you start at 6 feet. After 1 second, the ball reaches the maximum height. So if we were to graph this out at 0 seconds, 0 being the x coordinate, remember my compass students that are here every day, sit towards the back. And then anyone that's coming in new, sit in the front. So take any front seats. 0, 6, and then at 1 second, you're at 22 feet. And then hopefully you understand that then the ball starts falling. So this is an upside down parabola. So all I need is 2 coordinates, 0 seconds, 6 feet, input, output, 1 second, 22 feet, and that is the vertex. So really what we have is this exact question, except it's in a word problem format. I'd plug this in for H, this in for K. Wrong! Sorry, going fast sometimes kills. This is H, this is K, and then this is an arbitrary x comma y that you would plug in for that and those color codes and then do all of this work. So honestly, that's what that question is. Word problems, you just extract the important coordinates out and then do what you did on the previous one. Okay,